Where's the negative go? In front. So I have negative 2x sine x as a final answer there. So we do product rule on the first piece because it's a 2x times a cosine x. We do a normal derivative for the second piece. Put all the pieces together. Final answer. Questions? Comments? No? We're good? All right.
You said like that part was multiplying together?
No. That part was the second part of the product rule for this.
Just that one?
Yes.
Oh, because that...
Yeah. Does that make more sense?
Oh, yes.
Oh, okay. We're good. All right. All right. Let's look at example 2. First, and just kind of a side note from like the quiz, there should not have been a question on the quiz that you did not find a derivative on. Like if you forgot the directions entirely to the entire second half, like take a shot and take a derivative. Like at least do that. That'll get you half credit on every question. Okay? If you just did like random plugging it in with no derivatives, not going to help you. Nothing we have done, except for maybe average velocity, which didn't appear on the quiz. Nothing like that did not need a derivative. Okay? What kind of derivative rule should I use in example 2? Quotient rule. Good. Let's get my notes back up because everything dies when the Wi-Fi dies. All right, now in order to use quotient rule, I have one thing that I do have to fix or think about differently before I can use my quotient rule. What is it? The 1 over x. How do I think about the 1 over x? Negative exponent. 1x and negative 1. All right, so I'm going to think about this like this. Notice, have I even discussed the directions in this? Like past find the derivative. I don't care about that yet. Take the derivative first. All right, so let's walk through quotient rule on this. Hey, help me with quotient rule here. How do I start? Derivative of the top function for quotient rule. Okay, so when I take the derivative of the top, what is the derivative of the top? All right, so just going through that, what's the derivative of 3? Nothing. I don't care about it. When I take the derivative of this term, I bring the negative 1 down front, multiply, get 1x to the negative second. Okay, quotient rule then says multiply that by what? X plus 5. What comes next in quotient rule? Minus. Minus what? First, just the top. Times what? Derivative of the bottom. Are we all okay with the bottom being 1 as the derivative? Derivative of x is 1. Derivative of 5 is 0. All over what? X plus 5 squared. Now, here's your good news for this. Remember in 8.2 when we did this, I told you that I don't care about simplifying this. Because is this my answer to this question? No. My answer to this question is the equation of the tangent line. What do I need for the equation of the tangent line? First, I need what? Okay? I need like an x and a y. I have my x and my y right here. I need to find the slope. All right, so that was one of the direction sets on our quiz. How do you find the slope? Plug it in. So this is the main reason I've told you, I don't care if this is simplified. Can you plug in 1 to this in your calculator? Yes. Sure. I mean, go ahead and simplify if you want to. But let's do f prime of 1. So everyone grab a calculator. Now, when we're typing this in our calculator, we should be smart about this as well. Do I care about, for example, this times 1 over here at the far right-hand side? No, I did that for the purpose of the derivative, but I don't care about that in reality. Okay? So if I take a calculator now, you can use it. It's fine. I got lots.
Is it supposed to be
Negative 1?
Is that what you're using?
You're doing the derivative of the bottom, which is the x on the bottom. Yeah?
No, the x is negative 1.
Oh, sorry. Yeah. Negative 1. That's what we're talking about. There's so many ones. Yes, we're plugging in negative 1. All right, so make sure you use parentheses. First, I'm going to make one big fraction. If you don't know how to do that on the 84, that's alpha y equals, and then there's this like n over d thing. One big fraction. Then in parentheses, I'm going to do negative 1 to the negative 2 power times, in parentheses, negative 1 plus 5, close my parentheses, minus, in parentheses, 3 minus 1 times negative 1 to the negative 1 power. Lots of parentheses here, guys. On the bottom, I'm doing negative 1 plus 5 all squared. Let's see what we get from this. I got 0. Everyone see if you can type that in. I'm pretty confident that my answer is right. Anyone else getting 0? Or we're still typing? Well, yeah, I do this for a job, so. Now, let's talk about this. What did we just find? Slope. This is slope. Now, you can do the next step the easy way or the hard way. Okay? I'd love for you to think about it being the easy way. If you have a slope of 0, what kind of line is this?
Straight line.
Well, they're all straight lines.
A
Horizontal line. Okay? So I could go to y minus y1 equals m times x minus x1, but that would waste a lot of my time right here. If it's a horizontal line, it has the equation y equals a number. What is my y value that I've been given? 1. Now, if you insist on not doing that and doing it the hard way, it would look like this. Y minus 1 equals my slope times x minus negative 1. What happens to the entire right-hand side?
0.
Turns into 0 because that slope is 0. Then you would have to add 1 to both sides and you would still get
1.
Y equals 1. All right? So if it says equation of the tangent line, that means you want to find the derivative, find the slope by plugging in your x, and go to either point slope form or the easier y equals if you can do that here. Okay? Questions about 2? All right, for the sake of my time, I am leaving off example 3 right now. We will probably come back to it at the current moment in time. Yeah. All right. Let us, I'm going to come back to 4 if I have time. Let's go back to 5 on the back. All right. Real briefly, I want to talk about second derivatives. We panic because we're like, we don't know how to find first derivatives. The good news is that a second derivative is just the derivative of a derivative. So if I give you something like in example 5, could you find the derivative of the original function? All right, let's go through that one thing at a time. What's going to be my derivative of my first term? 4x cubed. Then what comes next? 6x squared minus 6x minus 1. All right, so we're all capable of finding that derivative. Good news, when you're finding the second derivative, you just do it again. I know. It has a purpose. The purpose is mainly physics, actually. Shocking. Usually where you see this in physics, you did position velocity acceleration. Position is the original one. Velocity is the first derivative. The acceleration is the second derivative. That's the main reason we do this in all reality. In calculus, there is application to it later that will come up, and we will get there. But for right now, it's just like a chain of derivatives. So f double prime, the second derivative, looks kind of like quotation marks. We just find the derivative of the derivative. So I would go from that 4x cubed, and I would say my derivative is what? 12x to the second plus 12x minus 6. What do you think the next question's asking you to do? Find the third derivative. I don't know. Let's just have fun doing that, right? Not necessarily like hard, though, guys. It's just like learning that you can do that. So the third derivative would just be taking the derivative of the second derivative. And since I just had to erase mine, I'm just going to have to say f triple prime would be what?
24x plus
24x plus 12.
Are we gonna keep doing that?
You could. At some point with the x's, what are you going to get to?
0.
0, right? Because if I did the fourth derivative, let's just say, for example, okay, I'm just going to say this for now, which, by the way, oddly enough, this now goes to like Roman numeral notation. The fourth derivative is like IV. I know. We don't usually like cross the top and bottom line, but we would say like the fourth derivative would be like 24, which means the fifth derivative, which that V is Roman numeral. What's the derivative of 24? 0. So at some point you'd like stop because every derivative after that would just be 0, right? Now that works for some of them, and others of them they go in cycles. Like with the x's, they go down by degree, so you run out of derivatives eventually. Let's quickly look at example 6 here, which will be like one of our last thing. Okay? What is the derivative of sine? Cosine. All right. So this one's not going to have a whole lot of work. We're just going to be writing down derivatives. The derivative of sine is cosine. We all okay with that? All right. So if I went to second derivative, what is the derivative of cosine? Negative sine, right? All right. Now what if I went to the third derivative? The derivative of sine is cosine. So what's the derivative of negative sine? Negative cosine. Now this one has like the seventh derivative, so let's just start numbering from here. Next is the fourth derivative. What's going to be the derivative of negative cosine? What's the derivative of cosine? It's a negative sign, so now the derivative of negative is going to be positive sine. All right, where are we back to? The original. So then if I did the fifth derivative, do I really have to think about it? I already know what this is. It's just cosine. And therefore the sixth would be negative sine. And my final, the seventh, would be negative cosine. Now I'm not going to make you do it, but you could, if they come in patterns like this, just think to yourself, this is really just in sets of 4. The original, and then 3 derivatives. And then it goes back to the original and the 3 derivatives, and so on. You could use the pattern of sets of 4 to find the derivative way far out. Okay? Now, because I got through the back page, I am going back to example 4. I am not doing example 3. Oh, well, get it back out. All right, last question, and I shall be done for the day. Okay? All right, so if we would like to find the equations of the tangent line to the graph of our function f of x that is parallel to that line, okay? We haven't done one that says this yet, but let's just not like panic. Let's say if I was just thinking equations of the tangent line, how do I start? Anything that we've done so far, we start with what? The derivative. Do we think we can find the derivative of this function? Maybe. Let's practice. What rule do I have to use for this? Quotient rule. How does my quotient rule start? F prime of x is equal to. How do I start? Derivative of what? The top. What is the derivative of the top? 1 times what? The bottom. What comes next in my quotient rule? Minus. The top times the derivative of what? The bottom. What's the derivative of the bottom? 1. All over what? The bottom squared. All right, now this one I would like to clean up part of this. Okay, what part can I clean up a little bit? Okay, I can't cancel right now because of the minus sign, but let's clean up the top. We all okay with cleaning up the top? That's going to be x minus 1 minus x minus 1, right? That 1 times the x minus 1 just gives me x minus 1, and then I distribute the negative. What's going to cancel? The x's. So what is my simplified derivative here? Negative 2 over x Oh, it is minus 1. Why did I write plus 1, guys? Tell me when I do it wrong. X minus 1 squared. All right, there's our derivative. Even if you know, like, nothing else to do after this, what I'm hoping to, like, get into your heads right now is just take the derivative first. Like, try something, okay? Now, let's worry about the second part. We want our line to be parallel to the given line. What's parallel mean? Same slope. Do we know what the slope of that line is? Right now, do we know what it is?
No.
We can find it. That's a good answer. How do I find the slope of that line? Solve for y. All right. So if I subtract x and do what? Divide by 2. I have this. What part of that do I care about? The slope. What's the slope? Negative 1/2. All right. So we found our derivative, and we found the part of this that I care about. It's the negative 1/2. What do I want to be true? I want my line to be parallel to this line. Okay? Now, I wasn't given a point, but it's going to be any equation where this is true, right? Any equation that has a slope of negative 1/2. Well, what else gives me my slope? What did we find already? The derivative. In other words, I want my derivative to be equal to that slope. Okay? If I set my derivative equal to that slope, is that something I can solve? Sure. How do I solve something that looks like that? You could do that. It's not a bad choice. Plug this into y1, the other one into y2, and see where they intersect. If we did not have that and we wanted to solve by hand, I would cross multiply. Okay? If I cross multiplied that, I'm going to get negative 4 is equal to negative x minus 1 squared. If I'd like to solve for x, what do I have to get rid of? It's like pulling teeth, guys. What do I have to get rid of? I'm going to have to square root it. What do I have to get rid of before I square root it? The negative. Divide by negative 1. It's going to turn everything positive. Then square root. When I square root, what must I not forget to put in front? Plus or minus. So then finally, what would I move? The negative 1. If I move the negative 1, that means I'm going to add it. So it's going to say x equals 1 plus or minus 2. Therefore, my x values are what? 3 and negative 1. Okay? Now, homework for this needs to be discussed briefly before we leave, because I'm sure you don't want me to tell you it's everything. Yeah? Pretty sure. So, homework for 8.4. Let's see. I think odds looks pretty good. Okay?
You grab my